Hi everyone, today we're going to talk about dimensioning techniques and the proper way to do these on single views and multi-views. So, to describe an object completely, you've got to tell both the shape and the size of the object. The shape we tell by the picture, but the size is done with dimensioning. So think about it. A machinist can't build a part, or a carpenter, they can't build a house unless all the sizes on the drawing are absolutely correct, and that's important. So what is another name for size description? Well, it's dimensioning. So the definition for dimensioning would be size description. So our standards for dimensioning, as far as our rules go, they're put in place by the ASME Y14.5-1994. ASME is the American Society of Mechanical Engineers, and in the Y14.5M-1994 is the code in their handbook that tells how to do these. So let's look at some techniques. This sheet that you see in front of you, this is one of my cheat sheets, and I've got this linked on the page, on our haiku page. So what we see here now, if you look over to the left, and I'm going to use my cursor over here, if you look over here to the left, this is a multi-view drawing, a front view and a top view, and I've added the dimensions to it. And then all this around it is notes and stuff, and I've also included a few notes in and around it as well. So when we dimension this object, if you notice what we've got is sort of a base shape here with a little angle cut off the end. It's got a cylinder sitting up on top of it, and then there's a hole cut down through the cylinder. So here's the angle cut off the end, or the chamfer, whichever one you prefer to call it. So when we dimension something, we've got some general rules, and we'll go over those in a minute. But this sheet, I would strongly advise you to get this sheet and be able to look at it whenever you can. Like I said, you can either download it or you can just bring it up on your computer screen, either one. So what we want to give is you always want to give your shorter dimensions closer to the object. And what do I mean by that? Well, if you notice here, what we've got is the size of this object, the size of this cylinder. So it's 2 inches in diameter. Now, if you notice, it's done where we see it as a rectangle. A cylinder is always dimensioned its diameter where we see it as a rectangle, not where we see it as a circle. The only thing we do as a circle is a hole. So we've gave this dimension, and notice it's a short dimension. It's only 2 inches long. And then we've gave the width of the angled cut. It's 1 inch long. Those dimensions always need to be closer to the object. So anytime you're dealing with features, that's what you want to do. The overall dimensions are placed outside of those. So how do we locate the hole in the cylinder? Well, if you notice here, what we've got, it's 3 inches in from the end and 1.5 inches up from the edge. And look what's happened here. Our center lines become extension lines. Okay, so this is the extension line. To get the dimension off of it, notice there's one here. There's one here. So all these are extension lines. And then the line with the number in it is the dimension line, okay? So I'm going to go on. I'm not going to talk much more about this drawing because we'll get into more of this later. But this is a great cheat sheet for you. Okay? So dimensioning includes measurements, notes, and symbols. And again, here's another cheat sheet for you. This one's just part of the PowerPoint, so you can look back at it. It's basically the same information that I gave you on the last one. So how do we place dimensions? Well, remember, we've got extension lines. This brings the object out. We never put numbers directly on the object. So we have to have extension lines to get them out. So these are vertical extension lines. These are horizontal extension lines. And here's some also. Then the line with the number in it is called the dimension line. A dimension line usually terminates with an arrowhead. Okay, it's 3/16 long. And it's about a 1/16 wide. All that's set up for you in AutoCAD, so you don't have to worry about it. And if you notice, the number is split in half by the dimension line. So in this case, this is the best case scenario. The arrowheads, the line, and the number all fit inside the extensions. Same thing with this long one here, 13.5. Everything fits inside. Well, what if everything won't fit inside? Well, the next best case scenario, the number fits inside and the arrows go outside. How about after that? Well, then everything comes outside. And if we've got a worst case scenario, we may have to point at it using a leader shoulder like that. Okay? So arrowheads again. we use what's called a filled arrowhead. In other words, it's solid. We don't do open ones. We don't do transparent ones. We usually use filled ones like this one. And notice it says 2.5 to 3 times its normal length, okay? So the width of this arrowhead is a 1/16. So 3 times would be 3/16. The arrowhead must touch what it's talking about. If you notice, every one of these arrowheads touch where we're going to. So if we're going to dimension a diameter, if we have a hole, there's a couple of ways of doing it. This is the most standard way as far as industry norms. If at all possible, we like to point at it from the outside. This is called a leader, what you see here. We point at the hole and give its diameter and size. This is one of the other options that we're seeing a lot now using AutoCAD, is we have the arrows here, and even on great big ones, a lot of times we'll have people now putting them inside the hole. But this is, again, this 1/2 inch, the most common way. This diameter here is probably the least common way of doing it. So these are all for holes. Now what if we have a cylinder? So this is a cylinder with a little button sticking up on it, and notice what we've got here. This is basically the shape. This is almost like a cap that fits on top of something. So notice the diameter of the cylinder, all 3 of them. So we've got a big cylinder, a smaller cylinder, and then the smallest cylinder. These are all given where they are rectangle shapes. We don't ever point at them where we see them as circles. So here, if you notice, what we've got is a 1.5 inch diameter, but then here we've got a circle out here. We should not give this here. If this is a cylinder, that number should be given where we see it as a rectangle. Okay, so how about dimensioning radius? So if we're dimensioning a radii, which of course is plural of radius, what do we do if we don't need to locate the centers, and what does that look like? If we have an inside radius, which is called a fillet, so we're filling in an area, or an outside radius, which is called a round. Now remember, AutoCAD calls everything fillet. If you're putting a curve between 2 lines, they're all called fillets on AutoCAD, but the proper name should be fillets and rounds. So what we've got here with these is we don't have the center point located. We don't have a little crosshair for our center point. But what we do is we point at it and let the arrow touch it and say this has a radius of 1/2. And all these are the same. Notice this one here is radius of 0.20. We've got a big one here, a radius of 5 inches. And then the outside ones, typically what we do is this one. We just point at it from the outside. You can point at it from the inside, but this is the more common one. So how about if we've got a radius that we need to locate the center? That would be if we've got an odd radius sort of floating out in the middle of nowhere. So look at this one. We don't have a true square corner that we're working off of. That makes it easy. We've got an angled line coming this way and an angled line coming this way. So this one's sort of floating out here. So you would locate it in from the edge and then up from the bottom in this case. And then we would give the radius here. And of course we could point at it from the outside instead of the inside. So our standard unit of measure is decimal inches. That's set up by ANSI. Now remember, ASME is the American Society of Mechanical Engineers. ANSI is the American National Standards Institute. They deal with the numbers that we use, the numerical values. Remember, decimal inches are a whole lot easier to read. They're a lot easier to do your math with and easier to deal with in fractions overall. We prefer to use 2 decimal places for most everyday use. But if you're in mechanical design and doing real nice machine parts, you're probably going to use more decimal points than that. But right now, we'll stay with 2. Metric, well, our base unit in metric is millimeter. And believe it or not, we use the millimeter all the way up to 10,000 millimeters. That's our standard unit of measure. The abbreviation for millimeter is mm. And if everything on the sheet is a millimeter measurement, we do not put that on it. Now, we may go down like near our title block, down at the bottom of the page, and write the word metric just so everybody knows for sure that it's metric, okay? And in the United States, both in our metric measurements and in our decimal inches, we use a period as a decimal point. To you, that makes common sense. But in a lot of countries that do not speak English, they use a comma. North America, everybody uses a decimal point or a period, but in other countries, they don't. So let's discuss leading and trailing zeros. A leading zero is a zero in front of a decimal point. A trailing zero is a zero that goes behind the decimal point. So in inches, we show trailing zeros. We do not show leading zeros. So like this is a quarter of an inch. All these are the 3 decimal places. So this is a quarter of an inch. Notice we don't put a zero out front in any of these. It's just 0.250. We add the O to get to 3 decimal places. A half of an inch, we have to add 2 zeros to get to 3 decimal places. And then for 7/8, we would go to 0.875, where the 3 decimal places were good. If we were working to 2 decimal places, it would be 0.25, 0.50, and 0.88. So with values greater than or equal to 1 inch or 1 unit, notice again, we put the number of trailing zeros in that we need, and of course our whole numbers go in front of the decimal points. Now for millimeters, it's just the opposite. We always show a leading zero in front of the decimal point if it's less than 1. We never show a trailing zero. Okay? So these are exactly opposite of these. It's easy to keep up with. Okay? And again, if the value is greater than 1, no trailing zeros in millimeters. So 1 millimeter is just 1. 1.5 millimeters is 1.5 instead of 1.50 like we would do for inches or 00. So I hope that makes sense. So here are a few rules, and we're just going to go through these fairly quickly. Here are a few rules that you need to follow anytime we're doing dimensioning. Okay, you need to make good use of these. Each dimension should be clearly showed and stated so that it can only be read, interpreted in one way and one way only. Don't ever give a dimension twice unless you absolutely need it for clarity. And every once in a while that might have to happen, but most of the time you only give it once. So we only give width attached to the front view and not to the top view, or attached to the top view, but don't do it also in the front view. Only give it once. So like if it's 5 inches wide, then put 5 inches attached to the front view or the top view, but not both. Dimensions need to be placed where they're best described. So anywhere we see the actual shape. Remember, the one exception on that is a cylinder is dimension diameter where it's shown as a rectangle. Okay? Place the dimension between the views if it applies to both views, and it'll help improve clarity. So in other words, again, if an object's 5 inches wide, try to put the number 5.00 between the front view and the top view. It'll make more sense. Stay away from really, really long extension lines or leader lines. Okay? Don't ever assume that a part's symmetrical. You're better off going ahead and dimensioning both sides of a symmetrical part just to avoid confusion. And you can use the center line to show symmetry if you want to. Spacing between dimensions should always be consistent. So you don't want a dimension 3/8 of an inch off in the front view and then a 1/2 inch off in the right side view. Okay? Line up dimensions horizontally and vertically if possible. This is called chaining dimensions. So you always want your dimensions, if you've got several in a row, you want them in a chain going across to where they look like they're all in one line. And don't ever cross a dimension line with a leader. Okay? If you'll use these notes, it'll be a lot easier to understand. One thing you want to do is like quantity. So this number 10 talks about using a 2x if there's 2 parts that are identical on the piece. You can use the 2x and then you give the part description. So if it's a hole and it has a 1/2 inch diameter and there's 2 of them, you can say 2x and then the diameter symbol and then 0.50, and that'll show it. And that's the end of the PowerPoint. So what you need to do now is go back and watch this again, make 10 notes off of this PowerPoint and submit those as your first assignment. Have a great day.